All right, geometry class, welcome back to the last lesson in the unit on polygons. So we're going to finish up with about trapezoids and kites. What have we learned so far? All of this stuff. We dealt with interior angles and exterior angles and all sorts of polygons, but we spent a considerable amount of time on quadrilaterals. We spent a considerable amount of time on parallelograms and special parallelograms. And now what we're going to do is end this whole thing with trapezoids and kites. Now notice what's happening in this diagram with trapezoids and kites. We no longer have two pairs of parallel sides. In the case of a trapezoid, only one pair of parallel sides. In the case of a kite, no parallel sides. So some interesting stuff is happening. Okay, so we got to pay attention and make sure we know everything we need to know. And we begin with notes. So we're going to cover all this stuff with angle measures and mid-segments and all these neat things, and we're going to cover that in the lesson. But let's talk about notes. What is going on with this thing called a trapezoid? So what is a trapezoid? It is a quadrilateral with only one pair of parallel sides. That is a trapezoid. Now, as you can see from the diagram, trapezoids come in two sizes. A trapezoid and isosceles trapezoid. There's that word isosceles again. And we have to remember it's a similar principles from isosceles triangles as well. But we have the thing called an isosceles trapezoid. So we'll learn about that. In the case of an isosceles trapezoid, we must understand some neat things are happening. Number one is that we have base angles congruent. Okay? Base angles are congruent. And the sides are congruent. Okay, just the sides. Not the bases, mind you, just the sides. Okay, so we have that is by definition an isosceles trapezoid, and we're going to learn some stuff with that. The other thing about isosceles trapezoids is that we have diagonals that are congruent. And if you remember, we've dealt with congruent diagonals before. Students, do you remember where congruent diagonals came in? Yes, we do. Congruent diagonals came in rectangles as well. So rectangles and isosceles trapezoids have similarities in the fact that their diagonals are congruent. We'll be using that information a little bit later. So those are some notes. If that was too quick, find, pause, and rewind. Now, we got some trapezoid stuff. This is really, really fun. And by fun, I mean challenging, because look, it's a fraction. Oh, no. So we have trapezoid mid-segments. Now what happens in a trapezoid mid-segment? If you recall, mid-segments is when we connect midpoints. We connect midpoints, we have a mid-segment. In the case of a trapezoid, we got some interesting things that happen. When you have a mid-segment of a trapezoid, not only is it parallel to the bases, it is also half the sum of the bases. Whoa. Not only is it parallel to the bases, it's half the sum of the bases. So that's an interesting thing as well. Now you can focus on this all you want, knock yourself out, and it's going to be challenging to read, but know the vocabulary, it's going to be much better, and that way you don't have to focus on fractions all the time. It's half the sum of the bases. Anyway, we'll see how that plays out later in the lessons. So we've got what we need about trapezoids. Well, what about this other thing called a kite? Now, kites are fun. Kite is a quadrilateral. It has no parallel sides, but it also has congruent side lengths, similar to a parallelogram. But if you remember, parallelograms had opposite sides that are congruent. In the case of a kite, it is consecutive sides that are congruent. Okay, so there are no parallel sides, but consecutive ones are congruent. We then have a kite. So there's some interesting things about a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. Where else have we seen perpendicular diagonals? Our friend, the rhombus. So we have to remember there's also a neat little similarity between a rhombus and a kite because our diagonals are perpendicular. So again, kite, no parallel sides, two pairs of consecutive congruent segments. And we'll start using some of those. Anyway, let's jump into some math and do some algebra. So here's our first little example of a question we might come across. We're talking about angle measures in trapezoids. CDEF is an isosceles trapezoid, and the measure of angle C is 65, given. What is angle D, angle E, and angle F? Now, we have learned something interesting just in this word isosceles trapezoid. In that word isosceles trapezoid, we have a whole lot of information that's just been given to us from this note. If you remember, we have an isosceles trapezoid. Our base angles are congruent. So if this angle is 65, well then, guess what? This angle is also 65. Yay! So we have found now the measure of angle F is 65. Neat. All because of that word isosceles. Now, for the other ones, we have to do some math, right? We've got angle D and angle F. We can do some math. There are a few ways to see how this math is going to unfold. How are we going to find the measure of angle D and the measure of angle E? One way to see this is by using the interior angle sum. We have a quadrilateral, a four-sided figure. Our interior angle sum of a four-sided figure, if you recall, is, you guessed it, 360 degrees, right? And minus 2 times 180. So the interior angle sum is 360. Now, knowing that information, what do? We have 65 degrees here and 65 degrees here. That's a total of 130 degrees. If we have a total of 130 degrees taken up so far, what is left for these two angles? Well, we just subtract, and then we'll end up with 230. So we know we have 230 degrees left to split between these two angles. Now, this is an isosceles trapezoid. So once again, what do we know? Those two base angles are congruent. They are congruent. So if they're congruent, that means they have the same degree measure. So what do? This 130? We can cut it right in half. If we divide that by 2, we end up with 115 degrees. So each of those angles is 115 degrees. So that means angle D is 115 and angle E is 115. That's one way of looking at it, only one way of looking at it, the interior angle sum. Another way of looking at it is the fact that we are dealing with an isosceles trapezoid. We can look at same side interior angles because we have parallel lines. Boom, boom, boom. If we have parallel lines, we've got to remember, same side interior angles add to 180. So we've got to remember that as well. Do we have to? No. But that's just one way of seeing this. Same side interior angles add to 180. So that means if one same side interior angle is 65, then the other one is, well, 180 minus 65. We can easily find that second angle just by looking at parallel lines. And voila, as we can see, 180 minus 65 is 115. So no matter what, we're going to get to the fact that our other two base angles are 115. Now, what did I just say? I said these are base angles. And you might be thinking, Mr. Katz, duh, those aren't the base angles because the base is down here. And I'll say, oh yeah, what have I been saying all year? Don't ever let gravity mess with you. Yes, they are base angles as well. So we got to remember when we talk about vocabulary, don't let gravity fool with you. We have two pairs of base angles in a trapezoid. Cool? Cool. So that's how we can find angle measures in trapezoids. Here's another example. Once again, gravity trying to mess with you. So here's a diagram, and again the diagram gives you an isosceles trapezoid, and the measure of angle R is 106 degrees. So we already know a whole bunch of stuff, So what are the other angle measures? Well, if this is a trapezoid and I don't want to let gravity mess with me too much, I can just do this, right? Then I know angle S is 106 degrees. And if I know that, I know we have parallel lines, and I know same side interior angles are supplementary. Holy cow, all this thing starts coming together. We now know our other base angles are going to be 74 degrees. So we have all the other angles that we need just by knowing some stuff. Now, where'd that 74 come from? So once again, these are same side interior angles. I should probably use a space there. So same side interior angles, and they add to 180 because we have parallel lines. Okay? The only reason we can say this is that we have parallel lines because we're in a trapezoid with one pair of parallel lines. So we have 180 minus 106, and that's where our 74 comes into play. All right? So that's how we can figure out all the other things. So the measure of angle P we had established was 74 degrees. The measure of angle Q was also 74 degrees. And the measure of angle S was 106. Okay? So remember, don't let gravity mess with you. So here comes another challenging question. This is a good one. So this is a neat word problem. Yay! With a picture. Yay! And the picture's kind of hard to figure out what's going on. So we read a little bit. The second ring of a paper fan shown at the right consists of 20 congruent isosceles trapezoids that appear to form circles. What's the measure of the base angles of these trapezoids? What is going on? We have a circle, and what we're doing is cutting that circle into a bunch of different triangles, and then we're cutting one of the triangles into trapezoids, isosceles trapezoids. So what's happening? Clearly, we're going to have to deal with angle measures, right? Because we're talking about base angles and angle measures. We have a circle. What do you know about circles and angle measures? Yes, a full circle is 360 degrees. We should know that. We should know that coming in. So we have a full circle that's 360 degrees, and we have this shape. Like the little cutout is what we're dealing with here. So the challenge is how we're going to find out what's going on. Now, all of these tiny little triangles have angles that come together and form the circle. So this is our angle that's in question. Because if I put all those 20 triangles together, I'm going to have that circle. So this little angle is the angle in question. So if we have a full circle that's 360 degrees, and we have 20 of those triangles, how are we going to find only one of those degree measures? Hopefully by now, you have figured it out. If we take our 360 and we divide it by the number of 20, because that's how many triangles there are, we would have the angle measure right there, okay, or the angle measure right there, whichever way you're looking, because it's the same thing, right? So of course we're going to have 18 degrees. So we have our 18-degree angle measure right there. Okay, now you're thinking, whoop-de-doo, what's the big deal with that? Well, if we have an 18-degree measure here, and we have an isosceles trapezoid, what do we now know? We now know the base angles. Because if you remember, isosceles triangles have congruent base angles. So if this measure is 18, and the full triangle, remember the degree measure of a triangle is 180. If I take away that 18 degrees, I'll be left with 162 degrees. Oh, I should probably show that in case you're not listening. So we have 162 degrees left between these two angles. So if 162 degrees between these two angles, what is that per angle? Of course, you realize if we divide that by 2, it's 81 degrees per angle. So we have an 81 degree measure down here and an 81 degree measure down here. So the only thing that's left to find are the other base angles, which is just like the previous examples. Okay, so this is kind of cool in the fact that we have taken the circle, divided by a thing, and then did some isosceles work, and knowing all of this vocabulary, it's so much fun because we can figure this stuff out. Neat puzzles. Anywho, let's finish. If this is 81 down here, then what is going to be my other base angle? Well, if same-side interior angles are supplementary, we can figure that out. It's going to be 99 degrees is what's going to be left. So our 99 degree angle measure is what is up there. So if we're looking at only the algebra, we know that our x degree measure is 81 and our y degree measure is 99. So yay, puzzles. Huh? Okay, let's do another example like that. We'll go a little bit quicker. If this was challenging, pause, rewind. We're all good. So another question, very, very similar. In this case, though, we have 15 congruent isosceles trapezoids. What's going to be the difference? So where is this 15 going to come in? What's the difference between this and the previous example? We still have a circle, so we're still doing 360. We still need to find the angle measure of our isosceles trapezoid or isosceles triangle. So if we divide that 360 by 15, we're going to be in good shape. So what is that, 25? So 360 divided by 15, no, that's not going to be 25. It'll be 24. So 360 divided by 15 should give us 24 degrees, I think. Yes. 15 goes into 32 times, the remainder is 6. So, yeah, 24. Anyhow, we now know our isosceles vertex angle of 24 degrees. If we know our vertex angle of 24 degrees, we can now find the base angles of the isosceles triangle. Okay, so that's what's next. How do we do that? Well, remember the triangle is a 180-degree interior angle sum. We have 24 of that taken up by the vertex angle, and so we subtract. We have 156 that is left between these two base angles. So if we have 156 between the both of them and they are congruent, we divide that by 2 and we have 78. So each of the base angles is 78. We now know our x. How, of course, will we find our y? Same side interior angles. Such fun. We have 102. So 102 is the degree measure that's left up for the other bases. Okay, so our x value is 78. Our y value is 102, just by knowing vocabulary. Isn't that cool? Not much math, just a lot of vocabulary. So that's how trapezoids work. But now let's talk about midsegments. This will be fun. Now, if you guys should know at home, I am recording in front of a live studio audience. We have a quiz right now that has an example just like this. Okay, so what we're going to do is figure this out. I'm going to help the students that are working on a quiz, and they're going to stay quiet because there's a live studio audience. Now, we have a midsegment of a trapezoid. What goes on with a midsegment of a trapezoid? If you remember the notes that we showed earlier, midsegments, not only are they parallel to the bases, they're also half the sum of the bases. Midsegments are half the sum of the bases. So, QR, that midsegment, is going to be half the sum of the other two bases. And the other two bases are 4x minus 10 and 8. So what's going to happen? We can add 4x minus 10 plus 8. That was a bad mistake. All right, there, plus 8. 4x minus 10 plus 8 then gives us 4x minus 2. That is now the sum of our bases, and x plus 2 is going to be half of that. So what is half of 4x minus 2? We can cut 4x minus 2 in half. Now, if you've ever seen something that looks like this, we have to recall how fractions work, because it's kind of cool. By the way, it's going to be 2x minus 1 if you don't know. But how does something like this work? This denominator of 2 applies to each of the terms in the numerator. Okay, so that's kind of how that plays out. Anyway, you end up with 2x minus 1. So half the sum of our bases is 2x minus 1. And guess what? The midsegment is equal to that. The midsegment was x minus 2. So it is x plus 2. It is x plus 2 that is equal to 2x minus 1. Okay? Now, some of you guys like to look at the examples in the book and do all that stuff, and you follow this, and there's fractions and parentheses and blah, 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 blah. I'm a big fan of reading and thinking. Okay, when you read and think, look at the difference between what you see in the textbook versus this. You can choose, because I really don't care one way or another. So all we have to do now here is solve for x. First thing I'm going to do, again, not showing work, I'm going to subtract x from both sides. I'm left with this. The next thing I'm going to do, again, not showing work, is add 1 to both sides. I'm left with x equaling 3. So that is the value of x. X equals 3. Now, how do we know? X plus 2, 3 plus 2 is 5. Okay. 4 times 3 is 12. 12 minus 10 is 2. So we had 5 here, 2 here, 8 here. Does that fit? Absolutely. We have 5 in the middle, 2 up top, 8 in the bottom. Does that fit the theorem? Yeah. 8 and 2 is 10. Half of that is 5. We win. X is 3. Okay, so that's how the midsegments of trapezoids work. Let's do another one. And then we'll almost be done because kites are pretty simple. So another example. Again, midsegment of a trapezoid is this. What is x? I'm going to go a little bit quicker now. So if you want to work this on your own, hit pause. But I'm going to go pretty quick. Because again, the midsegment is half the sum of the other bases. So watch what's going to happen. I'm going to add my bases real quick. 8x minus 12 plus 10 gives me 8x minus 2. Half of that is 4x minus 1. Okay, so I did that really, really quick. Half of that is 4x minus 1. And what is that equal to? It's equal to the midsegment, which is 2x plus 11. Okay? Or, again, like I said before, if you don't want to think and you just want to follow what's in the book, you can deal with all the fractions and percentages you want. Now, what do we do from here? Again, not showing work. I will subtract 2x from both sides, and then I will add 1 to both sides. And then I will divide both sides by 2, and I find that x is equal to 6. And then we'll just check our work super quick. X is equal to 6. 2 of that is 12. 12 plus 11 is 23. We got 10 up there. 8 times 6 is 48 minus 12. 48 minus 12 would be 34. So is 23 half of 44? No, I did something wrong. 48 minus 12. Did I do that correctly? 36. Nope, I didn't. Aha! There we go. Half of 46 is 23. That's better. Whew. So, check my work. Be careful. Anyway, x is 6. We are all set. Midsegments and trapezoids. All right, last thing, and then we're done. Kites. Kites are kind of fun. Now, what is a kite, if you remember? Kite is no parallel sides, but 2 consecutive congruent pairs. Okay, 2 sides that are congruent. So we know this information about kites. We also know kites intersect at 90-degree angles. If you remember that note from the beginning of the video, if I can find that paper there, there was a note in the beginning of the video about kites where they diagonals intersect at 90-degree angles, just like a rhombus. So if the diagonals intersect at 90-degree angles, guess what we now know? We now know the measure of angle 1. By the way, live studio audience, the other quiz question is this one. So we now know the measure of angle 1 is 90. Given, right? Because if this is 90, then this is 90. They're all perpendicular. Everything is 90. Angle 1 is 90. Now, here's what's interesting. This angle measure is 52 degrees, right? Right in here. So what is the measure then of angle 3? How are we going to figure that out without using any math? Check this out. If we have 90 degrees here and 52 degrees here, we also have 90 degrees here. We can figure out angle 3. How's that going to work? Well, we have a hypotenuse and a leg. Do you remember hypotenuse-leg congruency theorem? Yes, I hope you do. If this is a 90-degree angle, we have a hypotenuse that is congruent. We have a leg that is congruent. We have triangles that are congruent. And all corresponding parts of a triangle are congruent. So if that's the case, and this angle in here is 52 degrees, what does that mean about this angle? Also 52 degrees. So angle 3, 52 degrees, no math required, just vocabulary. So the only other question then is, what is angle 2? So we have to figure out this angle 2. We have a 90-degree angle here in the middle. We have a 52-degree angle up at the top, if you want to say top. I don't like using that in geometry. And we're going to have a total of 142 degrees. So what's left for angle 2? We take 142 from 180, and we have what's left. So that would be 38. So the measure of angle 2 is 38. So just by knowing hypotenuse-leg theorem and remembering about congruent triangles, we can know all sorts of stuff about a kite. Isn't that cool? So we have like a bunch of congruent triangles going on here. So that's how we can work with a kite. Am I done with kites? No, I got a couple more. Here's another question. It's very, very similar. Okay, so quadrilateral blank is a kite. So what do we know? We know we have 2 pairs of consecutive congruent sides. And we know we have 90-degree angles in the intersection of the diagonal, which means we have congruent triangles because of hypotenuse leg, which means we have all sorts of stuff. Now clearly, angle 1, again, 90 degrees. If this angle in here is given as 36 degrees right in here, we know angle 3. Angle 3 is also 36 degrees. If we know angle 3 is 36 degrees, we can find angle 2 by doing a little bit of math. We add 90 and 36 to get 126. We take that from 180. And then we have 54 degrees is our leftover. So angle 2 is 54 degrees. So all by knowing some neat things, boy, we can get a lot of stuff done. So for the live audience, there's your quiz for that last section. Fun stuff. All right, so we're going to end this with a quick quiz, super fast. So here's a quiz. In kite NPRQ, angle PNT is 34 degrees as shown. PNT, though. Look at this picture, dudes. Like, where is that angle? Now we have to read. PNT. 34 degrees is here. Okay, so we've got to make sure that we are reading carefully because the way that diagram is written, we don't know. The question then, what is the angle of RPT? So now we need to find this angle. So we have a kite, so we have a 90-degree angle. We have a 90-degree angle. We were given a 34-degree angle. It's 124. We're going to take that from 180. And then we will have our result, which would be 56A. Right? So the angle of, the measure of angle RPT is A. So just like that is kites. Anyway, that is it, ladies and gentlemen, for the unit on polygons. I hope you have enjoyed it. I hope you learned some stuff. These things can be fun. But yeah, I'll see you on the flip side for the next unit. Peace.